Hello, good morning. Today we are going to see the Poynting theorem. So what Poynting has stated. So Poynting has given a very good explanation of how an electromagnetic wave carries the power, or we can say how the power flow can be identified using the Poynting theorem. So let us begin with the statement of the Poynting theorem. It states that the vector product of E and H at any point gives us the measure of rate of energy transfer at that point. It further states that the direction of this energy flow is in the direction of vector E cross H, and this direction is always perpendicular to both E and H. It means that the vector E and H are are in the same plane and the direction of energy flow is perpendicular to this plane. Then let us look at the third point, which gives us the Poynting vector P is equal to the cross product of E and H. So from this equation we do find that this is providing us in the numerator we find it's a product of voltage and current, and in the denominator it's a square meter, or simply it's nothing but the energy density. So it's a power watt per square meter. Let us find out the detailed derivation of the Poynting theorem. So let us look at the first sentence. So as I stated, electromagnetic waves carry with them electromagnetic power. So to prove this, we'll take the Maxwell's equations. So these Maxwell's equations are, first is del cross E bar is equal to minus dou V bar by dou T. Second Maxwell equation is del cross H is equal to J plus dou D by dou T. So this, in the second equation, first term J indicates the conduction current density, and second equation provides us the displacement current density. So from the vector identity we can write the divergence of E cross H is equal to this equation we can write. So using this vector identity we can substitute the equation number 1 and 2 in equation number 3, so which provides us a equation like this. So if we do find that in a simple medium where parameters are like conductivity sigma, permittivity epsilon and permeability mu, if they don't vary with time, okay, if these parameters are taken as a constant, then we can write for the one part in the equation number 4 as like this, that is dot product of magnetic field intensity with the dou B by dou T as the dou by dou T is equal to 1 by 2 mu square. Similarly, for the second part in the equation number 4, we can write as finally means if we begin with E bar dot dou D by dou T as dou by dou T of 1 by 2 epsilon into E square. Then similarly the third part in the equation number 4 can be expanded as E dot J is equal to E dot sigma into E bar. So in this we find a dot product of two vectors. This further can be written as a sigma into E square. Okay, let us see further. So equation 4 we can write like this: divergence of E cross H bar is equal to like this. So it is a combination of two terms are taken together, and then the term is negative sigma into E square. So if we integrate this equation on both sides throughout the volume, so we do find that left hand side of the equation becomes a divergence of, means volume integration of divergence of E cross H dV is equal to, this can be expressed as a volume integration. So if we apply the divergence theorem to this equation, so we get an equation like this. So the divergence theorem provides us a relation between the surface integration and the volume integration. So this equation gets converted to this after applying the divergence theorem. So we can interpret what finally we get from this equation as the first term indicates the rate of decrease of energy stored in electric and magnetic fields, that is this term, and second term indicates the ohmic power dissipated as heat in the volume. So here we can comment as like from the Poynting theorem we do find that there is a rate of decrease of energy stored in the electric and magnetic fields and the power dissipated in the medium itself. So this indicates that when an electromagnetic wave travels from one point to the another point, so it carries the energy with it, and this energy decreases as it travels further from the source. Now we'll see the time average of the power density. Since we have seen in the beginning like cross product of E and H as the energy density, that is watt per square meter. So if we take an equation for electric field, if it is along x direction like this, magnetic field along y direction, and if we do take an product of these two equations being a time average of power density, so this will provide us an Ex0 square by eta into cos square omega t minus beta z. So to find out the average power density, above equation for Pz is integrated over the one cycle and divided by the period 1 by f. So if we take an time average of this, so this cos square omega t minus beta z is expressed as in 1 plus cos of 2 omega t minus 2 beta z. And if we solve this equation, then we reach to an equation that is an Pz average is equal to 1 by 2 Ex0 square by eta. So using this equation we can find out the average power. So this is the density, average power density, since it is watt per square meter, and this equation, if this is being multiplied by the area, we can find out the power flow in an electromagnetic wave. Thank you.